Welcome back, Year 10. Today we're going to go through the required practical for photosynthesis. Now, as I've already alluded to, when we're measuring the rate of photosynthesis, we can either measure the rate of which carbon dioxide is taken up, or we can measure the rate at which oxygen is produced or glucose is produced. Today we're going to look at the required practical, which looks at measuring the products of photosynthesis, and in this case it will be oxygen. So we're going to be using pondweed or Eladia, and pondweed obviously lives in ponds which is underwater. This allows it to give off visible bubbles of oxygen, and we can count those bubbles. The light intensity can be changed by moving the lamp either closer or further away from the pondweed, and we often think about doing this in a lab situation where we can control all of the other factors. So we can control things like the temperature of the water, so it's at the optimum level for photosynthesis. So we're going to start off with, what do we think our hypothesis is? That's a bit like, is our prediction, and that's what we think is going to happen. So the first task that I want you to do is pause the video and write down your hypothesis. What do you think is going to happen? So again, we need to make sure that we're including our and statements. So linking the distance from the lamp to the rate of photosynthesis. Take a minute to finish the hypothesis on the screen, filling in the blanks. So before we get started, you may have seen this practical in your revision guides. You may have seen this practical before in Year 9. And you may have seen this on some other YouTube videos. So we're going to think about this. Now we're going to need to plan our experiment. This is often a 6-mark question in exams. And these are the points that they're looking for. They're asking you to either write an apparatus list or an equipment list. You need to draw a diagram. Now this is a bit of a complicated practical to set up. So what it was really useful sometimes is to draw or sketch a quick diagram, show how you're going to set it up, and label it. Then there's no need for a list. And your first step of your method can be set up the equipment as shown, which takes away all of the wordy explanations. Decide what variables you're going to investigate. So if you're going to investigate light intensity, which distances are you going to do? So you may want to do it at every 10 centimetres or 20 centimetres. Okay, and you're going to start off as close to your pondweed as you can and moving further away. Now, counting bubbles for each period of time. You might decide that you want to count how many bubbles for 30 seconds and then double it to calculate the number of bubbles per minute. You may decide that you're going to count the bubbles for a whole minute. What you're going to do is you're going to need to record this, decide on a method and record this in a table. What will you use to count time, how long you count the bubbles for? Have you included a stopwatch in your equipment apparatus? And how many times are you going to carry out each experiment? Now you need to remember, the more repeats you do, the more accurate your results will be. However, it's sometimes just not practical to carry things out 10, 15 times. So we do have to think about the number of repeats and what is workable for us. So which control variables will you control and how? So which things are we going to need to make sure we keep the same during each experiment? You might think about using the same piece of pondweed, the same wattage in the lamp. Okay, so we're making sure that the lamp is giving out the same light intensity. Okay, think about why it wouldn't be a good idea to maybe use the torch off of your phone in comparison to maybe a desk lamp for another set of readings. You might also want to get the same person counting the bubbles to reduce the effects of human error. You may want to make sure that between moving the lamp each time, that you keep the lamp there for 3 minutes to allow the pondweed to acclimatise to the new light intensity. What effect would any of these have if you didn't keep them the same? This is something for those of you working 4 or above, you need to think about explaining in your answers. So lastly, what are the safety considerations of this experiment? Now, we're obviously using electricity. We've got a lot of water and we've got a lot of glassware. Think about your risks and how you could control them. It's really important that we work safely. So now you've got an idea about your method. Write down a method of how to carry this out. So obviously you're stuck at home, we're stuck in school. We can't be sending home loads of pondweed via Amazon. So what we're going to do is use a simulator. We're going to use the simulator on the next slide to repeat the investigation. What you're going to do is change the light intensity by changing the distance. So using the slider across the bottom of the screen, using the beat per minute counter. So you literally tap the counter on the screen and it, or the space bar, and it will count the number of bubbles for you. So there are different things that you can do. What I want you to do is sketch your results table. Now, if you haven't already done so, can you pause, go and get a ruler, pencil, and sketch out your results table. So here we are. Now, if you click on the link at the top of the screen, you can see we've got our sample of pondweed in our test tube, and you can see it's upside down. We call that inverted, okay, and that's so that the bubbles can come out of the top of the pondweed. Along the bottom of the screen we've got our slider, and we can move our lamp, which is the nice white line just above the middle, up and down that slider starting at 100 millimeters. If you're unsure about any of the instructions, there are a set of instructions that you can follow, and they will talk you through them and give you a couple of demonstrations. What you're going to do is you're going to take readings at 100, 120, 140, 160, 180 and 200 millimeters. Now, because this is a computer simulation, I'm not going to ask you to repeat any of those readings because you get exactly the same reading each time. So what I want you to think about is take readings for each of those, and then you're going to answer the following 3 questions. You're going to describe how the rate of photosynthesis changes as the change in light intensity. You're going to say what conclusions you can make from your results. Use your results to support your conclusions. Okay? You will get more marks in an assessment for saying, I can see this because at 100 I got 20 bubbles, whereas at 200 I only got 5 bubbles. Okay? And sometimes it's practical, the water heats up from the lamp. Why might this be a problem? And what can we do to control this? So think about those questions. Answer those questions in your own words. Go back a slide and you will be able to click on the link and follow the link to the website.